mechanics. We're going to look at 2.2.14, which is state Newton's third law of motion, and then we will look at some examples of Newton's third law of motion. So, Newton's third law of motion. This is given by a Marx scheme. When two bodies, A and B, interact, the force that A exerts on B is equal and opposite to the force that B exerts on A. In other words, if A pushes B, B pushes A, with the same size force but in opposite direction. Okay, we'll look at some examples of that. For every reaction there is an equal and opposite reaction. So let's take a reaction. The reaction must be of the same kind, for example, gravitational or electrostatic force, the same kind of force. It must be of the same magnitude, but it must be in the opposite direction. This Newton's third law is always true, So we can look at one example here. There's a weight pushing down on the table. The books push on the table. Therefore, a Newton's third law pair is that the table pushes up on the books. The books push on the table push up on the books. This is the reaction. The books push on the table pushes up on the books. These forces will be the same size and in opposite directions. Newton's third law of motion. The student would answer, for every action there's an equal and opposite reaction. In the Marx scheme it said, no marks awarded, learnt without understanding. So be careful. This is what was given in a Marx scheme once. Okay, we're going to look at some different examples here. This is a rocket traveling through space. Okay? We know it is accelerating upwards. There's a force pushing down. The rocket is pushing the fuel out of the back of the rocket downwards. If the rocket is pushing the fuel must be pushing the rocket, and this is why the rocket accelerates forward. So the rocket pushes the fuel downwards, which means that the fuel pushes the rocket upwards. This is a Newton's third law pair. The rocket pushes fuel, fuel pushes rocket. The earth pulls down on the books, the table pushes up on the books. The books pull up on the earth, the books push down on the table. Now which force goes with which force? Which ones are the Newton's third law pair? Well, this is the earth pulls down on the books. Therefore, books pull up on the earth. These two are Newton's third law pair of forces. Earth on books, books on earth. This is another pair of forces. The table pushes up on the books push down on the table. This is another third law pair. Notice that the forces will be the equal size, but they're not the equal type. This is a gravitational force. The earth pulling down on the books is a gravitational force. The books pulling up with a gravitational force on the earth is gravitational. The table pushing up on the books is an electrostatic force. The reason there's a contact force is because there are electrostatic forces between the particles, which make it a hard surface. Misunderstanding. Some people think that when you add up the forces that adds up to zero. This is the same as Newton's third law pair. No, it's not true. A sum of forces might be zero, and if there's an unbalanced force it will cause acceleration. Newton's third law is always the case that for every force there's an opposite force of the same size. Let's look at this example. This is a confusion that often people have. Some people say the reaction is the table pushing up on the books, and the gravity is pulling down on the books. This is a Newton's third law pair. It is not a third law pair. What we have here is the table pushing on the books and the earth pulling on the books. They're two different forces acting on the same object. They're balanced by chance, and therefore there will be no acceleration. But this is not a third law pair. So this is just about balancing forces. The weight is a gravitational force. The reaction is an electrostatic force, a contact force. This is not third law power because they're different kinds of forces and they're all acting on the same body on the books. Let's look at this. The table pushes up on the books and the books push down on the table. Yes, table on books, books on table. This is a Newton's third law power. So they're both the same kind of force. They're the contact force and they're therefore electrostatic. Let's look at this. The earth pulls the books down. So the earth is pulling on the books. A Newton's third law pair would be the books pull on the earth. The earth pulls down on the books pull up on the earth, which means there's a force pulling the earth towards the books. It's a fairly small force because it's the weight of the books, and you're not going to notice it on the earth because the earth is so big. But there you have it.